Okay, so this video is going to look at completing the square, and particularly by the end of this video you'd want to be able to complete the square for a quadratic expression in its basic form where you just have x squared at the front, and then to be able to solve quadratics by completing the square, which is another method that you can use to do that. So here is an example where I've kept the question very simple, so just saying complete the square for this quadratic. And so that might be a start point, but it's not always going to be that straightforward. There are different ways the questions can be phrased. So completing the square means to write this quadratic so that you have a single bracket squared, whereas factorizing you'd have two separate brackets. In this one single bracket squared. And then you will need some other term outside, which although it says add b in this form, it could be minus b. And similarly in the brackets, instead of add a, it could be minus a. But that's the kind of format that you're going for when completing the square. And I'll try and explain as I go through this why it's called completing the square as well. So to start with, when you're solving this problem, you want to look at the value that is in the middle there multiplying x, the coefficient of x, if you like. So it's a positive 6. And the most straightforward thing you can do to start with is that the value inside the bracket, the a, is going to be half this value here. So we're going to start off with by saying that our completed square form will be x plus 3 squared plus b. Now, other than telling you that it is half that, you need to also understand, well, why is it half that? Where did that come from? So if we was to expand x plus 3 squared, we would end up getting the expression, or this particular part of x squared plus 6x plus 9. And you'll notice that this matches the original quadratic expression we got. We've got this x squared plus 6x. Those parts match, but the problem is the number at the end doesn't. Now the x plus 3 squared is considered a perfect square on its own. But because this perfect square on its own does not get us back to the original, it's incomplete. It needs something else at the end. That's where this b comes into it. And so completing the square means to put some other value added or subtracted at the end to balance it back to what you want. So at the minute, when we expand this, we get plus 9, but in the original, we had minus 5. So you have to think, well, what would I have to do afterwards, once I've expanded this bracket, to get from a positive 9 back to a negative 5? And to do that, you would need to subtract 14. So our final answer is to have x plus 3 squared minus 14, and that is our completed square form. Now there are other advantages to this when it comes to graphing quadratics as well, but the next thing we're going to look at is how we could actually use this in solving an equation. But before that, there is an exam style question that we're going to look at. So here is a question how it could be written in an exam, where we have our quadratic and then we're asked to write it in this form. Now it doesn't say complete the square at any point, but that is what you would need to do to get it into that form. So going through the processes that we went through before, you could do that. Now if you want to pause the video and have a go, then do so now, but here we go through the answer. So to start off with, I recognize I do need to halve the number that is multiplying the x, the coefficient of x. So it was plus 12, so it's going to be plus 6 inside my brackets. Then I've gone through the process of expanding that bracket. I've written the working out fully here, and yes, I'm getting the x squared and the 12x, but instead I've got plus 36 at the end, whereas what I really need to have is the minus 1. So in order to make that change, to get from a plus 36 back to a negative 1, I would need to subtract 37. And now I have my answer in the completed square form. And so that is one type of question you could get. Another type you could get is to actually say solve a quadratic using the completing the square method. Now the reason you might need to complete the square is that if you try to factorize this quadratic, you'll realize it won't work. You can't find two numbers that multiply to make positive 2 that are going to add together to make a negative 6. It doesn't work. Whereas completing the square can give you a solution and would be very useful in a non-calculator type paper. So going through the processes, the number that's multiplying x is negative 6. So inside my bracket, I need a negative 3. Then this will lead us to eventually, once we've expanded and figured everything out, that we'd have to subtract 7. Once we expand this bracket, we'd get a plus 9 at the end. and so we'd have to subtract 7 from there to get to plus 2 in our original form. Now, because it's an equation, it's always equaling 0 because that's what it said at the start. And once we get to this point, it's a case of inverse operations to solve it. So you'd start off by removing that minus 7 that's on the left-hand side by adding 7 to both sides. Your next step would be to square root. And at this point, I am going to indicate that the square root could be positive or negative, because this will help us with our two solutions at the end. On the left, I'm just left with x minus 3, so the final stage would be to add 3. And when I've done that to both sides, I've written it in this format, 3 plus minus the square root of 7. Now, when you are solving quadratics, there can typically be two solutions, or you need to be aware of the potential for two solutions. One where you are adding that square root, and one when you're subtracting it. So, final stage would be to write two separate solutions, one where we've got 3 plus root 7, and one where we've got 3 minus root 7. And that is how you could solve a quadratic equation using the completing the square method. Hopefully this video has been useful. If you want to leave any comments or anything, just do so below. Thanks.